Hello, today we'll be doing Leetcode number 814, binary tree pruning. So for this problem, we're being given the root of a binary tree which only contains ones and zeros in its nodes, and we want to return the same tree but with every single subtree that don't contain a 1 removed. And by definition, a subtree of a node is that node plus every single descendant of it. So for this example, the subtree of the root node would be like this entire tree, and then say like the subtree of this node would be all of this, and if a subtree of this leaf node would just be itself. So just walking through the examples, as we can see with the first tree, we're removing this node from the tree because this is considered a subtree. A node by itself is considered a subtree, and this subtree doesn't contain any ones and it's a 0, so we want to go ahead and remove this. But as for this 0, we don't want to remove this because, as we can see, the subtree of it contains a 1. There is a descendant that is a 1, so we don't want to remove that. And this is our resulting tree from this removal. And for the second example, as we can see, this entire side of the tree are just all 0, so we'll just go ahead and prune that off. And so then on the right side, we also have just a node by itself, a 0 node by itself, so we also want to prune that off. And this is our resulting tree, and this gave us a tree of just ones. So I've went ahead and just made a bigger example so that we can see the problem better. So starting from the root, we have a 0, but because the subtree still contains 1 in it, we don't want to remove this node. And then moving on to the left, as we can see, this is the same as the root. It's a 0, but we don't want to remove it because we can see that the subtree contains a 1 in it. Now moving to 1, this subtree is just a 1, so we don't want to remove it. Now moving on here, we can see that this entire subtree are zeros, so we can go ahead and just prune this off. And then moving on to the right, we can see that the first node on the right is a 0, so we don't want to remove that. The next node is a 0, but same case as the root node and this node, we don't want to remove it because the subtree still contains a 1. So how do we solve this problem? Well, we know that we can only remove a node from the tree if the subtree of it, which is the node itself and all of its descendants, don't contain a 1. And if it contains a 1 anywhere, then we can't remove the subtree. So what can we do? Well, we can do a depth first search and we can traverse through the nodes. And so just starting from the root, as we can see, this root is a 0, but we don't want to we want to check if the rest of the subtree contains a 1 anywhere, and we can see this next node is a 0, but we want to keep looking and we can see that, oh, here's a 1. So then we can go back and we know to not remove this node, but going to the right, we can see that here's another 0 node, and now we want to keep traversing to see if there's a 1 anywhere in the subtree. And as we can see, we traverse to the only child it has, which is a 0. So this means that we can actually remove this entire subtree because this entire subtree doesn't contain a 1 anywhere, so we can go ahead and prune this off. Now onto the other side, we can see that this node is a 1, so we won't prune this. And moving on to the next node, this is a 0, but we want to keep going because it still has children that we can visit. And then moving on to 1, we can see that because this is a 1, that means that this subtree contains a 1 somewhere, so we don't want to remove this node. So because this tree only contains zeros and ones, we can actually indicate whether or not a node is to be removed by just with Boolean statements. So we'll be using a depth first search, so we'll go all the way to the leaf node, and as we can see, we have a 1 and there's no further descendants to be explored. So because this is a 1, that means that this subtree contains a 1. So this means that the parent's subtree will also contain a 1, because a subtree is defined by the node itself and all of its descendants. So here we will return a true. And then going all the way down here, we can see that there's no further children, but this is a 0 node, so we know to remove this, and we will return a false as well. And here we can see that there's no other children, and all of the children returned a false, so we will also remove this node, and this will end up returning a false as well. Now we get back to this node, we can see that even though one side of it returned a false in terms of whether or not there's a 1, the other side returned a true. So because we're looking at the entire subtree, there is a 1 somewhere in the subtree, so we won't be removing this node, but we remove these 2 nodes. Now, going back, we will also return true because there was a 1 somewhere here. Now, going all the way down here, we can see that here we have a 1, and we will return a true again because the subtree contains a 1. And then here we can see that even though we have a 0 node, we don't want to remove this because its subtree contains a 1, and we know from this true statement. And here we just have a 1, so we'll return that. And as we can see, for the root node, both sides had a 1, so we don't want to remove this node because this entire subtree has 1 somewhere in the tree. Now this algorithm would give us O of n space complexity. O of n time complexity, but also O of n space complexity, whether you do iterative or recursive for the depth first search implementation. If you do recursive, which I will be doing, it will give you O of n space due to the stack usage. So as I mentioned, we will want to do recursive depth first search on this tree. So here I will define that. And what we want to do, so if we reached just a null node, then we want to go ahead and return false. There's nothing here. Now we also want to keep 2 variables, one for the left subtree in which we traverse depth first search. We use the depth first search function to traverse the left side of the subtree, and a right one for the same thing but on the right subtree. And now this will go all the way to the end, and what we will do for each iteration, we'll return the node value itself, and we will compare that against the left and the right. And if the node value is 0 and the left and the right are all zeros, then this will also return 0. But if any of it is a 1, we want to return 1, so we will do OR statements. And here we want to check, so if the left subtree gave us a 0, that means that we can prune off this entire thing. And to prune it, we will just set the left to none, so no dot left is none, or null for other languages, but for Python it's none. And also we want to check the same exact thing for the right, so prune off the right if the entire subtree ended up being a 0. And this is actually it for our depth first search function. Now we want to also consider, so what if we had a tree of just zeros? So that means we ended up pruning off the entire tree. So what we want to do is return null, or none in Python again. So to do that, we know that the entire tree only contained a 0 if this function returned a false, because that means that at no point there was a 1 in the tree. So what we want to return is we will run, we will return the root if we will return a tree if the depth first search ended up returning a true in the end. But if it didn't return a true at any point, in which this would return false, then we would want to return null or none. And this should run. So as we can see, this ran pretty efficiently. Let me know if you have any questions in the comments below, and like and subscribe if you enjoyed this video. Bye!